how am I going to do this? So that's a new piece of information. Good looking thing. How on earth am I going to work it? Hello, I'm Robin Vincent and welcome to Molten Modular DIY. Today I'm going to have a go at building the Ginkosynthese sample slicer. What's a sample slicer? It's a module for Eurorack into which you pump some audio and it'll sample it, slice it up into 16 slices and then let you sequence and CV the heck out of it. It's a couple of years old. I've had the kit a while. I bought it during their Kickstarter when they first introduced it in 2018. And it was kind of like one of the first kits I ever bought. But because I hadn't built anything at that time, I kind of needed to build other things first before I could bring myself to the point of building something that seemed, at the time, pretty intense. Having a look at it now, I have to say, and it's like, oh yeah, no bother, look at that, there's loads of room on these PCBs. I've been soldering Bafako stuff, you know, I can do much denser stuff than this. So it looks totally achievable. So it's about 9:30 now in the morning. I plan to get this done. Could I get it done by lunchtime? That seems like a tall order, but you know, you never know. The last Bafako thing I did took about 4 or 5 hours, and that was dense and chunky, that Perkle. Whereas this looks all right at this point. But you know, I think when building kits you tend to get into the style of one maker, and I've made quite a few Bafako kits, so I'm kind of zoned into the way they do things. Whereas this, I have no clue how the manual's going to run, how easy it is to follow, and how this exactly is going to come together. But all I could do is try. There seems to be a later manual available online, version 1.4, so that's what I'm going to follow. But you know, I tend to do it in reference to the piece of paper that comes with the kit, because I tend to believe that the thing that comes with the kit is going to be raw and true, and if there have been some updates it's worth noting what they are, because it's possible that new board revisions come out or different component sets get sent out, so it's not always a given that an updated manual will mean that will work exactly with your old kit that you've had knocking around gathering dust for a couple of years. So I'm just gonna, you know, I'll look at both and see how that works, but let's get stuck into taking the stuff out of the bag and having a look, see what we've got. Well, first of all, here are these two PCBs. Front board and backboard. Front board and backboard. See, that's good labelling. I don't mind that at all. I know where I stand with that kind of thing. I mean, if you look at the front panel, it is relatively straightforward. Bunch of patch sockets down here, 4 knobs, bunch of LEDs, I suspect some switches. Yeah, this is nice. Nicely made. So let's have a look in the bag. We've got some resistors, some knobs, power cable, ICs and IC holders. Oh, these red things, I know what these are now. Those are most likely a bag of capacitors. Patch sockets and the knobs. Transistors. Bunch of resistors. So that, what are those? Oh, those would have been diodes in that case. Bunch of resistors, stack of LEDs, and some headers. Doesn't look too bad. Now, I'm a little bit scared by my own level of confidence. I'm going, yeah, I could do this, no problem. So I'm, you know, inevitably going to completely stuff it up. But let's see where it takes us. So it says it's easy. It says it's easy in the manual. That's great. Get your desk ready. Get the tools together. Soldering iron. Yeah, got that. Got that on. Soldering tin. What? A what? I guess they mean solder. Yeah. Is that what you mean? I guess it is. I guess that's what he means. A cutter. All right. So some of those. Good advice. Good advice, Mr. Ginkosynthese. So following the next steps in order, as it is written down, After each step, flip the board and clip off the wires. Great. Start with the backboard. Right, let's get everything out of the way. Front panel over there. Backboard, that's the front board. This one here is the backboard. Let's go with that. So the order that they're saying things in is diodes, resistors, capacitors, then a crystal, then ICs and IC sockets, then more capacitors, then take a coffee. Alright. Now the screen print on the board is relatively small. My poor old eyes. I might have to do this whole thing with my magnifying glasses on. But that's alright. It's really well labelled, I have to say. As long as you can get close enough to read it. So let me get the bits and pieces out before we go to time lapse. So I need diodes. I've got D3 to D12. That gives me what, 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10. Yes. 10 of those and 2 of the fat ones. So got all of that. And then it's resistors. This is going to be a bit trickier because all of the components are for both boards. There's no of saying anything else. So I've got brown ones and I've got some blue ones and I've got some independent ones. And I've got a little thing all by itself. Okay, so it gives me the colours, 1K, 100K of all of those. So that's not going to be too hard to find out. 1K is brown, black. Yeah, you don't want me to go through all the colours. So I think what I'll do is I'll get these diodes and resistors in. That seems like a good start. And then we'll come back and think about these capacitors because they're looking slightly more difficult at the moment. So the only thing of note, of course, is with diodes, they go one way round. It's marked on the board nice and clearly. You've got a stripe which corresponds with the black stripe on the diode, or the grey stripe on the fatter diodes. So that's the only thing to remember, otherwise resistors going in any old way. So I'll get stuck in. Okay, point of order. These resistors, right? Looking at the new manual says that the 1K resistors are blue and are brown, black, brown. Now I've got some blue resistors here. These are blue resistors. See down here. But they are red, black, red, brown, or brown, red, black, red, one or the other. So these are not those. They're not what they're saying. So this is where keeping hold of that older manual comes in, because in the older manual, the 1K resistors are brown, black, red. See, that's why you check these things. You can't rely on an updated manual to be absolutely applicable to your kit. Of course it is in the absolute majority of cases, but you need to keep the other one to hand because there may be discrepancies. I mean, all this means is that in the kits that he sent out later on, he used a different brand of resistor. That's all. So the ones that come in my kit are these brown ones here, which are brown, black, red, with sort of gold on the end. I think that's the ones that he's referring to. But there's the right number of these, so that's the other clue. There's 17 of these, and that's how many that I need. So there you go. I just thought I'd point that out. I'm sorry to interrupt the flow of the time-lapsed soldering, but now I'll get on and do these resistors. Okay, that's the resistors and diodes. Nice. It's really quite a beautiful looking board, and I've even taken the trouble to put them all around the same way so it looks nice. See, that can be nice sometimes. It is a good looking board. Right, these capacitors I wanted to check. Is this the same? Yes, it is, although the online manual refers to a colour. I don't necessarily know that will be the same. So I've got to find the 22 pico, the 10 nano and the 100 nano and the 330 nanos. I do have this one rogue one that came in the resistors bag. I don't know. Let's have a look in here then. These are 100 nano. Whoops. Which is kind of what I was expecting. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And there's one more than I need for this particular board. So those are definitely a group. Here I've got 10, 3, 4, 5, 6. It says on them 10, very helpfully. So I'm going to take a guess that that's 10 nanofarads. That's 100 nanofarads. This is 10, probably. 22, look, got a big 22 on it, so that must be what those are. C1 and C2. This one, 330. 23 and 24. Good, right, so I have this lot. So I don't want to worry about that one for now. That's the crystal. Going to get to in a minute. These ones are well, I don't know about these red ones as such. Put those out the way. And the electrolytic ones, they'll all come later. I'll do the capacitors and the crystal. These capacitors and the little crystal. And we'll stop then and have a look at all the IC sockets. Alright. Oh, and just to say that these sorts of capacitors, they're not polarized, so they can go in any way round. Doesn't matter which way round as far as orientation goes. Because, see, I got told off about not saying enough about orientation, so I'm trying to overdo the orientation. It's like with the crystal, right? I don't believe that's got an orientation either, so you can go it that way up or this way up. Alright? See you in a bit. Okay, that's looking pretty smart. Looking pretty smart, I think. I definitely think that. Now, next up is the 78L05s. Now, it says that these look like transistors. Okay, 7805, as opposed to those which must be transistors, which we'll come on to in a moment. So we've got these two little fellas to put in. They can only go one way round. I mean, it's marked on the shape of the top of the 78L05 is marked on the screen print as well, so it can't go in the wrong way around. Well, it can, obviously. You could force anything if that's your bag, man, if that's what you want to do. But assuming that you want to do it right, then it's no problem. No problem. So here's all my ICs, IC holders, ta-da, on the other side. And again, you've got little nicks here to show you which way round they go. And similarly on the board, a little bit less clear on the board. Normally you would have something more like the nick out of here, like the little circle, little half circle. Whereas this time around, I think it shows you the pin 1 by this little gap in it here. At least that's what I'm going with. That seems to be right. It seems to say that on the documentation. Place the IC sockets with the gap towards pin 1, the square pad. Okay, look, the square pad on this is pin 1. You know, I never knew that. That's a new piece of information. Pin 1, square pad. Okay, good indication. Good indication, like that. Okay. Great, well I'm going to put those in and we'll stop again before the final batch of capacitors. Okay, another point of order. The IC sockets, these little ones, when you put them on the board, say here, it covers up the screen print. So you can't see what chip goes in this socket, because once you put that on there, you can no longer see what's written there. Now, it may well be easy. There may only be one sort of chip, but I don't think there is. I think there's different ones. And there's no sort of picture or circuit diagram in the instructions to show to refer back to. So once you've soldered that in, unless you remember, you don't actually know what to put in that socket. That's a bit of a bind. So what I'm going to do is I'm going to take a picture of this before I do it so that I can remember. So this lot here, well, this lot here are all the same, so that should be alright. These ones over here, slightly different. Anyway, back to it. The other slight bit of trouble I had there was that the IC holders are lower, shallower, whatever you like, than these components here. So ideally, and the crystal as well, ideally IC sockets should go in first, because then it's easier to lie it flat to solder. As soon as you get things which are higher, it's not going to sit right when you're trying to solder, so it's harder to get these things flat. So I had to use bits of foam and stuff to stick in there to make that happen. Which is alright, you know, I got around it, but when doing an order in how to solder things, if you are a manufacturer of a URAT kit, then do it in high order. Do it in high order, so IC sockets come before these big chunky bits that stick up, don't they? That makes more sense. At least in my view, in my limited experience and view, I think those things are right. So, final bunch of capacitors, which are these chunkier ones, I think, for this board. We have 80 picofarads, small red Wimmers. Now, I'm going to make a stretch. These are called Wimmers, are they? See, that says 2.5 on it. Does that make any difference? Oh, look, it says Wima. It's supposed to be 820. And there's supposed to be 25, 26, 23 of those. So it must be those. This side it says 820. What's it supposed to be? 820 picofarad. So there you go. That is right. It is labelled on there. Right, so those three go into 25, 26 and 27. Now these ones again have no orientation as far as I can tell. Let me just make sure I have them all and then I can solder them. So I need 47 and they should be two of those, and they should be the electrolytic ones. 47. That's a 47 microfarad. Cool, yeah. So with these ones, the long leg is positive. It says so on here. Look, a big negative on the side. On the shorter leg, long leg positive. On the board where these go, which is 3031, on the PCB, the square pad is also marked with a minus sign. And that refers to, obviously, the minus leg, the shorter leg. So these have to go in this way around. Longer leg into the round one, shorter leg into the square hole. Yeah? Longer leg there because that's positive. Negative goes into that square hole. Like so. Cool, that's those ones. 10 microfarad. There are 32, 33, 3 of these, supposedly. And same deal. 32 to 34. 32 is there. Negative goes to the shorter leg. Cool, that's those in. So we've got 2 big reds and 3 little reds to put in. Oh, there's also a power header that needs to go on this thing here, just to finish off this board. This power header goes on here, I think. Should be placed on the back. Oh, right, it's got to go on that side. Right, that's good to know. Good to know. Power goes on that side. It shows you where it goes. We'll do that one in a minute. So I'll do these bits, then I'm going to grab a coffee, and we'll come back and see where we are. So that's that board done. Which board? The back board, front board, back board. Back board done. Seems to be a couple of bits for a header to put on there, probably when it's all going together. We'll worry about that when that happens. So now we're moving on to the front board. This is the one that's going to have, there's a whole bunch of LEDs, all the patch sockets, knobs and stuff. Lovely job. And look, just look at the acres of space. There are. That's fabulous. I really like that. So what I'm going to do, I'll stick in all the resistors and capacitors and the transistors with the time lapse, and then we'll come back together to do all the front panel stuff, which is always more interesting to do in real time, I feel. So I will see you then. Look at that, looking nice. Remember, these transistors have to go the right way around, but it's all printed on the screen print. So although you can absolutely put them in the wrong way around, you would have to try hard to do that, I think. Now there's something else I mentioned in here before we get to the rest of the headers, which is this little jumper here. There's a, I've not lost it. There's a tiny little thing here, a little jumper and a thing. Let me show you what I mean. These 2 items here, and it essentially closes a circuit which switches between 2 functions. I don't properly understand the 2 functions. It talks about it if you want to have an alternative tracking for the start point. Start point of the sample, I guess. He says that his advice is to leave it open unless you want note tracking on the start point. It says leave open for normal start point tracking, close for 1 volt per octave tracking on the start point. I mean, don't you really want 1 volt per octave tracking? I don't know. I don't know. So maybe it's sort of talking about some kind of level of quantization, and do you want quantization if you're dealing with pitch of samples and things like that? I don't know. I mean, I guess I'm going to have to play with the module and see what I think at that point, but I think it's important to have this in here as an available thing. So I'm assuming that just goes through, and I just got to have it sort of nicely flat. But again, this is something, look, these are all so high. How am I supposed to put that in successfully? See, that's a pain, that is. So I guess I'll put a bit of plastic down and try to push against that to keep it as flat as humanly possible. So if we put it down flat, so like that. Put some solder on, keep it flat, and then let go so if it doesn't melt the solder at the moment. Doesn't want it. I don't want it to melt the plastic. See, that's in. It's a little wonky, but it's wonky in the right direction, and it's bent up, so I'm going to be able to get the little thing on there. My fan thing is a little fierce in places, keeps blowing stuff away. So as advised, I will leave this just on one leg so it's open for the moment. Like that. Yeah, right, what's next? Connection headers. In the next step, you're going to make a connection between the backboard and the front board. Yes. For this, you need to cut the two male headers, so the pokey, spiky ones, to the size of the female headers. Alright, so have you seen this? That's slightly too big. See, you've got too many. Same on the other one. Like so. So you have to cut this edge off, I'm assuming. Put the male headers in the female headers and place them with the female headers on the component side of the backboard. Then place the front board over the male headers. So first thing I've got to do is cut these down. I assume I just do that. I mean, I've never done this. Oh. Oh, right, that's hilarious. So yeah, I was a bit worried about what to do about that, and they just snap off. I had no idea. Oh no, see, I've done that wrong. Ah, damn it. Damn it. I thought that was going to go right, and it completely didn't. But anyway, I'm going to keep those in there. See, that snapped off on the wrong place. So, you know, that was great on the first one. The second one, no, I completely blew it. So, oh, darn it. So I'm going to have to just cut that away there. Woo! Right. That was a bit of a shame. That's not going to come out well. Well, no, it is. Once it's soldered in, once these are soldered in, sorry about the cockerel, once these are soldered in, it'll be fine. So they want the female side. That's a big blocky side. It's the, you know, the more intelligent dynamic side goes in to into the backboard, whereas the stupid idiot side, pokey side, goes into the other one. So put the male headers in the female headers. Yes, place them with the female headers on the component side of the backboard. Now this is the backboard component side, female headers, like that. Okay, wrong one. There, that's good. And then this has to go all the way over here into that one. So those are as wonky as you can imagine anything to be wonky. So how am I going to do this? So I'm going to have to put this board on first. But it can't go like that. It can't go like that. Alright, super dodgy then. I don't know. Because... okay, well that goes on the component side of the backboard. Then place the front board. Mind that you place the front board facing the components away. Yeah. So, because this is going to have all the knobs on, this has to be up. It's just that the screen print suggests that the headers go in this side of the board. Yeah? The screen print tends to show you where things go. So actually, strictly speaking, the screen print should be on this side. That's where it should be, and then that would make a little bit more sense. But as it is, it goes this way round. And I've now got to get these two wobbly things to wobble together. Alright, try to give it a little bit more thought. Right, there we go. Alright, that's in. Then this side. Okay, it's in. It just has the potential to be really rocky. And of course, I've got all these bloody components in the way. So my my ability to solder these, oh, it's going to be flipping tricky. Right, okay. So let's just set this down for a moment. If I don't push too hard, that should be alright. So if I just do an edge and an edge, it should be totally fine. But I've got to just not press too hard. Maybe I'll try over here first. Come on. Let's just have a look. Oh, of course it's still not in the bottom bit. Okay, that looks pretty straight. That looks pretty straight in there. So I'm going to go along with the rest of this soldering. So the headers are in. Now I've got to put it apart in order to do the rest of it. What's next? Pots and stuff. Then jacks, switches, LEDs. You are finished. Well, I probably need to put the ICs in at some point, I imagine, but we'll get to that in a minute. Oh my goodness, calibration. Oh, that's always my favourite thing, but that's later down the bottom, so let's stick with where we are at the moment. So the headers are done. Did that. Now I want the pots, LEDs, jacks, and switches. It says don't solder anything before you've lined it all out. Lined it all up, I should think. So put the pots on, but don't solder. Right, so this old chestnut, where we have to place all of these bits, oh, these lovely bits, onto the board, but you don't solder anything until it's attached to the front panel. So that's the plan, right? So, pots first. Pots. One, speed, pitch, length, and start. It says these are the green ones. So these ones here, the other ones are blue. Okay, so these are the regular pots. And these, they can only go in one way because of the 3 legs and the 2 legs. So they pop in there. Hold themselves in more or less quite nicely. Good. Those are all in. Don't solder. So then we've got a log and a lin. Oh, okay, so we've got attenuation and gain. One is linear, one is logarithmic, and apparently it's those letters underneath. One with an A and one with a B. You can see those. So the A is gain and the B is attenuation. Attenuation, which is there. And gain over here. Lovely. Don't solder. Place all the jacks. They all just seem to run along the bottom without too much bother. Again, for alignment, you've got 2 pins at the front, 1 at the back. Has to fit one way round. Don't solder. Switches. Slide switches. Got 2 of those. Go there and there. Tool switch. Oh, okay, that's what that fella is. Tool switch, S3. S3. Just feels like it. There we go. There we go. And then the other switch is S4, which I can't see. There. S4 in the middle. Like that. Place the front panel, tighten it with a few nuts. Easy does it. Oh, this was supposed to be in there. Which way around? That's supposed to go in there. Okay, good. Got that in. Everything else seems pretty solid, I have to say. So I'm going to stick a nut on there to hold it. One over here. Okay, place the front panel, tighten a few nuts, tighten at least 1 or 2 potentiometers and a few jacks. Yeah, did that. If you think it is aligned, then start soldering the components while the front panel is keeping them right. Yeah, I think it's good. Now, at this tantalizing moment, I'm going to break for lunch. Haha, so I didn't quite manage to finish it before lunch. You know, I had to go, so I've been at it, so about 2 hours, I suppose. 2 hours I've put into that. Very nearly there, though. So I'll come back after I have something to eat, and we can finish it off. Right, let's solder all of these parts on. So I've got all the parts, the switches. Oh, that's gone. That's fallen out. Oh, got one that's fallen out. So I'm going to put a bit of tape over those 2 bits in the hope that they will stay in. Let's get soldering. Let's do these switches first. So those bits are all soldered in, I think. Let's have a look and see if these switches survived all right. Yep, seem to have done. Everything's there. Button. Those bits. Yep. All good. Now I've got to take this off, take the front panel off in order to do the LEDs. Okay, back here. This appears to be the LEDs. I think that'll be it. There should be another one knocking around somewhere down here. It says mind the directions. The long pin should be the positive. Long pin positive. Already talked about that. And then what we'll have to do is that these will stick up through their little bits, and I'll use a magic bit of masking tape in order to do that. So, long leg positive. Positive is all down this side here. Long leg positive. So that should go like that. And unlike anything else, you don't bend the legs at the back because you don't want them to stay all the way down like this. You want them to come up to the front panel. Long leg positive. Long leg positive. Good, that's the lot. So, back on with this. As the rain falls down. I'm going to tighten it up with a couple of these again. But I can kind of put them all on at this point. Right, so when I turn it over, I want all of the lovely LEDs to appear in their little holes, is the plan. So I could push it down from the... No, that's not going to work. And to make them stick, we'll stick some masking tape across it. Across here. Well, do I want to do that? Because these lights actually stick through. They're not the flat ones which go flush. So let's not do that for a minute. Let's think about it. Maybe all I want to do is get them put in, you know, like that. So it's sticking through. If I can do that on all of them, maybe that's going to hold it enough to make it work. But they're all sticking out. Look at that. That's pretty awesome. Pretty awesome. They're all sticking through. And they're going to hang like that. Gravity's going to work for us in this instance. So yeah, that's going to do that. Just like that. Let's go. Not having to worry. Something tells me that's too easy. That worked too well. You must have done something wrong. You've forgotten something. No. And they're all the same orientation. All long leg on this side. Got my eyes, as far as I can tell. Yeah, just do it. Do it. Do it, do it, do it, do it. Look at that. Flipping awesome. Right, just got to get rid of all these bits on the end without getting them in my eye. Great, so let's put the rest of the bits on. Before the final putting together. And then got to calibrate. I don't understand. Anyway, we're going to have to work out how to calibrate this thing, what that means. Do we need to find special tools from somewhere? Don't know. We'll see. We shall see. Right. So let's bring all of these back to the fully anti-clockwise. Put the knobs on. Looks like they can only go one way around. They've got a flat bit inside the knob, which must correspond to the flat bit on the pot, one assumes. And then what pushes in? Ow! Spiky. That's just how it works. Seems to be. I might have to push it back. No, that's good. So if I push it down too far, it might drag on the faceplate. Oh, there's too many things to think about. Looking smart. Now we have to fit the two together. You are finished, it says. No, because we haven't put the two things together yet, have we? So obviously we haven't finished. So this needs to go together, but I also need to put the ICs in. Now I don't tend to put the ICs in early on, just in case I end up having to resolder something and then blow it up. I don't know whether that's a realistic thing or not. So I need my little tool, which is this, for straightening IC legs. Very popular tool this, people keep remarking on it, and so they should, because it's just the greatest thing. So what you do is you put your little IC in here and you go squeeze, and it makes the legs straight so they fit straight in to your holder like that. Now here's a problem. This is clashing with this capacitor right here. It's not going to go down. It's not going to go down. Oh dear. What to do? What to do? Bend it like that. Okay, that's what's to do. Yeah, alright, awesome. That's another fix. There you go. Now then, that's the only one that I know where it goes. The rest of these are a little bit in doubt because I can't really see the writing inside. Okay, these two ones here. No, it's still upside down. Okay, that's a 320. That's a 49 something. Let's have a look on these. 320, 49 something. There's only one of those, so that's the 320. This one here. So I can see inside just about enough to spot what it is. 4921. And with these, your little dot, you've either got a nick out the front or a little dot. That goes for the nick and pin 1 on your IC holder. 492, 4921, that's exactly what that is. Goes in there. Yeah, no, I can't see what they are. But there's the only 4 left. So it has to be right. Has to be right. Right, got to put the two things together now. This and this. Should we get it the right way? Up. Looks like it's going to go this way. Like so. So everything's in. I've got all the bits. That's all in. All the ICs are in. Nothing obviously missing at this point. So this should just lovingly and nicely go together. That's not the right way around. Let's try it this way round. Yes, that goes together well then. Look, see those, they match up. So match up there, push them together. That's it. There's no screw to hold it together or anything like that. It's just going to be held together on the firmness of those teeth. That seems to be all right. There you go. That is done. Look at that. It's a good looking thing. How on earth am I going to work it? Don't know, but I haven't got there yet because I've got other things to do. So we're finished. Right, time to power it on for the first time. Oh my goodness me. Let's put our cable in. Red stripe over there. Yeah. So it needs to be calibrated. Before you start, make sure nothing is plugged into it. Okay, turn the gain knob fully anti-clockwise. Power on while pressing down the sample button and the pitch mode button. Keep these buttons pressed down for about 30 seconds and the LEDs, wow, 30 seconds, the LEDs will light up one by one. When calibration is finished, you will see a binary code on the LED. Ignore it! Ignore it! Great, okay. This is the voltage it is calibrating to. Now restart the module and push the pitch mode button after you've powered up. Restart one more time. That's it. So, okay, so that's the build done. I'm going to have to take this over there, plug it in, and see if I can do that calibration thing. And my absolute assumption is that it's just going to work. Now, sadly, at this point, everything went a little bit pear-shaped. Now, the calibration worked fine. Sadly, I seem to have lost the video on that, but you know, you did what the instructions said and you turned it on with the thing over there, and it did it. It worked, and everything seemed to be coming together. However, when I started trying to use it, I discovered that there was something very, very wrong. Something wrong about the clocking. I couldn't seem to change the speed of anything. I couldn't clock it from elsewhere. Whatever sort of clock signal I put in, it would just maintain its own steady rhythm of beep, 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 which is kind of fun. Everything else appeared to work. I could record a sample, I could pitch it up and down, but I couldn't change the speed, and so I could never get it in time with anything else, with any sequence, and it very quickly lost its joy. You could say, so I took it apart and I resoldered and I checked this and I checked that, resoldered this. It turned out, in fact, that one of the three-pronged ICs that was in there needed to be upside down because they'd changed it or something, and that increased the sensitivity because the potential was that it wasn't really picking up the clock signal and needed to be more sensitive, and then it would. It didn't work either. So I spent quite a bit of time resoldering, taking things out, putting the things back in, resoldering, retrying, retesting, and just really not getting anywhere. Thankfully, Jan over at Ginkosynthese got in touch and says, look, let's see if we can sort this out. And we went through a whole bunch of things. I sent him photographs and bits of video, and he couldn't seem to work out what on earth would be causing this problem. So eventually sent it back to him. He had a look, and guess what? The problem, it wasn't me. It wasn't me. It wasn't my fault. It wasn't my build. The problem was with the surface mounted processor that was on the board. The thing that came with the kit already done. There was something that wasn't quite right, that I don't know, a pad had lifted or something had not made a connection properly, and so he reflowed the solder on that, bang, and it works. But unfortunately other things got in the way, and I haven't had time to really sit down and have a look at it since I was able to just confirm that it was working, which was great. But then I needed to finish this video off, and as you can see, my hair has grown and everything's got older since we actually put the project together back in Modular DIY week. But never mind, we're there now, and I will do other videos on properly how you use this and use it brilliantly, but I just wanted to show a quick demo just to finish off this build video. And also to say that despite the problem I had at the end, the build was good. It was a couple of hours, 2 to 3 hours. The board was really nice. The boards were beautiful, in fact. The layout was gorgeous. The space was brilliant. You know, and the instructions for what they were, which were not particularly in depth, were good enough. And hopefully if you're getting through this build, then what I said about it during the build will be helpful to you. But the one thing that was perhaps lacking in the manual was there was kind of no instructions on how you use it. So when I was testing it and not getting things working right, I didn't really know what it was I was supposed to get out of the outputs. Anyway, was I doing it right? Was it work? I had no clue because there was nothing that told you what anything did. So you kind of just got to feel your way through it. I mean, I guess there's videos out there that you could watch that will probably tell you a bit more about it. But honestly, mate, you could do with just a simple crib sheet on this knob does this, this knob does that. Treat us as idiots, because we are ultimately idiots. And it would be great to get that kind of level of information. So let me give you the 2-minute tour. Well, inevitably it's me, isn't it? It's going to be a 10-minute tour. And I'll just show you very quickly what it is the sample slicer does. So here it is. Very, very simply. You've got 4 knobs. You've got a row of LEDs. You've got a sample button. That's pretty much all you need to know. And then what you do is you sample into it and play with the result. So I've got a microphone here. 1, 2, 1, 2. So you hit sample. I'm just going to put it back to its default position, which is having the start point over on number 1 and having the length all the way across. I hit sample, and I can hopefully, with a bit of luck, record my voice, and then that will be. And that will be playable with. Put it into loop mode. Hopefully with a bit of luck record my voice, and then that will be, and I can hopefully with a bit of luck record my voice, and then that will be, and I can hopefully with a bit of luck record my voice, and then that will be, and I can hopefully with a record my voice, and record my voice, and then that will be, and I can. So as it loops round, you can change the pitch. With a bit of luck record my voice, and that will be. And I can hopefully with a bit of luck record. You can change the length. And I can hopefully with a bit of luck, and I can or change the start. And I with a bit of my voice, with a bit and hopefully luck record my voice, and then that with a bit, and I huddle up, and that will be and that listen board mic with a bit and hurry with a bit of luck with a bit of luck with a bit record with a bit of luck record with a bit of luck with a bit of luck with a bit of luck with a bit of luck. And hopefully that you can see that if I was to plug in some kind of CV, for instance, into the start point, then that would move that about. And I can hopefully huddle up, and I hopefully huddle up, and I hopefully can call, and I can hopefully call, and I can call, and I obviously you've also got CV control over length, you've got it over pitch. Now there's a different mode which is pitch mode. With a bit and call, and I with a bit record, and I with a bit record with a bit, which I don't fully understand, but I can put in into the pitch. And I with a bit channel 4 and hopefully can call with a bit and hopefully and I with a bit Alright, I mean that sounds pretty random, I suppose, but I guess if you were to put it in with a bunch of other things, if we could get that to work. And if I perhaps, sample through it, something a little bit more than just talking. Bum 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 So yeah, as you can see, it's a load of fun. It's a load of fun. You don't have to put your voice into it, don't have to sample anything like that. You can just put the output of another module into it and then start playing with that and playing around with it. I mean, this is not some kind of pristine sampler device. This is 12-bit, a bit crunchy, a bit rough around the edges, but such enormous fun and a way of bringing yourself into your module that you weren't really thinking of, perhaps, before. So yeah, the Ginkosynthese Sampleslicer MkII, this is it. I hope you enjoyed the build and that little demo, and hopefully I'll be able to use it in a few more things at another time. And if that's been a useful video to you, then do think about subscribing on Patreon or on YouTube. Throw me a few quid. That's always nice. Tons and tons of videos coming along, lots more modular DIY, along with other things. Synthesizers I seem to be doing a lot more of now, software, audio interfaces, all sorts of music technology, and don't forget my monthly Molten Music Monthly roundup of all the news and cool stuff that's happening in the industry. So there you go. In the meantime, go make some tunes.